Hello everyone, myself Krishabh Gupta. I am from International Institute of Professional Studies, a college located on esteemed campus of TAVV University, Indore. I am pursuing MTech IT and this video is a part of my college assignment given to us by Dr. Shaligram Prajapat sir. Here we are to solve the end semester examination paper of numerical analysis design. So in previous videos, we have talked about the multiple choice questions related to numerical integration and interpolation. And other than that, our internal test first paper was also solved, in which we had various questions. Similarly, we have questions here. So let's move on to them. So the first question is find the roots of the polynomial x square minus x minus 1 through fixed point iteration method. Also make a table for the various possible equations and show their natures whether they are convergent or divergent in nature. So here we will take two values in the equation fx is equal to x square minus x minus 1. So putting 1 we have 1 minus 1 minus 1, so we get a negative value. So in f1 we get a negative value, and similarly in f2 we get a positive value because 2 square minus 2 minus 1 is equal to plus 1. So we take the median value, which is 1.5, and here the function fx is equal to x square minus x minus 1. It can be written in various formations, one of which is x under root x plus 1, 1 upon x minus 1, and 1 by x plus 1, and the last one is x square minus 1. Here to select the correct g of x, here are two conditions: that the g dash x should be less than 1, mod of g dash x should be less than 1. If there are multiple values that are less than 1, we take the smallest one. So here, observing all these options, we have the first one, which is under root x plus 1, is not only it is less than 1, but in both cases for g dash 1 and g dash 2, and all the other values are not fitting the criteria, so we take under root x plus 1. In the next step we solve it for the gx is equal to under root x plus 1. Here we are performing operations. We are putting x0 is equal to 1.5. In the next step we are putting x1 is equal to 1.5811, the value which was the answer of previous step. And in the next step we perform similar operations up until we get a very small error, like such as between x7 and x is the error is only 0.000101, and it can easily be neglected. So our root of x square minus x minus 1 is 1.61800. Pardon me for the previous camera angle, it was kind of interfering with my presentation. So now looking at the page again, we have uh, two conditions: that g dash x mod of g dash x should be less than 1, and multiple values of gx are less than 1, when then we take the smallest one. So gx is equal to under root x plus 1 is taken. Now we will solve it for the values. Here our median value was x0, which is 1.5. We will put it in the equation. For next step, x1 is equal to x0 plus 1, which comes out to be 1.5811. Similarly, x2 is equal to x1 plus 1, under root x1 plus 1, which comes out to be 1.6065. Then yet again x3, x4, x5, x6, we will keep solving until we get two values with a very minor difference between them. As we can see, x7 and x6 have very less, or we can say very minor difference between them, which is 0.000101. So we can neglect these values, and our answer, the root of x square minus x minus 1, comes out to be 1.61800. Moving on to the next question, we have find the solution of the system of equations using iterative method. The given equations are 20a plus b minus 2c is equal to 17, 3a plus 20b minus c is equal to minus 18, and 2a minus 3b plus 20c is equal to 17. Here, on putting on the value of a0, b0 and c0, we obtain a1 is equal to 0.85, b1 is equal to minus 0.9, and c1 is equal to 0.85. Similarly, the value of a2, b2 and c2 can be obtained, which are displayed in the screen in front of you. a2 is equal to 0.98, b2 is equal to minus 0.985, and c2 is equal to 0.63. And similarly, we can obtain the values of a3, b3 and c3, which are our final answers 0.96225, B3 is equal to minus 1.0155, and C3 is equal to 0.6042. This is the answer of this respective question. For the next question, we have list out 4 disadvantages of Gauss elimination and 3 advantages of iterative method over the elimination method. The iterative method is superior to elimination method due to computational effort is approximately 2n to the power 2 arithmetic operation per iteration, and if convergence is achieved in less than n iteration, it is significantly superior and compared to the elimination method. Another important advantage of iterative method is small rounding error being the one committed to last iteration. This means for ill-conditioned system, an iterative method is a good choice prior to the Gauss elimination method. In Gauss-Seidel method, we set xi equal to the newly calculated value of the iterated stored in temporary value. Now, as per the disadvantages of Gauss elimination, the computational effort is approx 2 and by 3, which is quite high. The amount of bookkeeping is necessary. The amount of bookkeeping necessary is considerable. That means you have to keep track of a lot of values. The rounding error may become quite large, particularly for ill-conditioned equation, which is not ideal because the computer has to perform a lot more computations in order to keep the value correct or error free, and special structure in the matrix of coefficient is difficult to preserve during elimination. So these are the advantages and disadvantages of Gauss elimination over iterative method. For the next question, we are asked to write the algorithm for Lagrange inverse interpolation. So proceeding to the first step, we have to read all the inputs, read number of inputs n, then read the value of given x reference to the question. Then we will implement a for loop from I starting from 0 to n minus 1, where we will read the values of referencing abscissas and ordinates, which are xi and yi. Then we take a variables as sum is equal to 0. Then we implement a for loop from I is equal to 0 to I is equal to n minus 1, and we set product is equal to 1 because we cannot take product as 0, and to prevent any garbage value we are putting it as 1. Then we take another for loop inside of that, which limits j is equal to 0 to j is equal to n minus 1, and inside it we put a expression, we put a condition, which is if I is not equal to j, then put then put product is equal to product into y minus yi by yi minus yj. Then after this for loop is over, we will have an expression sum is equal to sum plus xi into product. Then we can print the result as print sum. This is the algorithm for Lagrange inverse interpolation. Thank you. For the next question, we are to evaluate the expression using 3-point Gauss quadrature formula for the given abscissas and weights. So here our question is dx by 1 plus x square from limit 0 to 1. Here the value of w1, w2 and w3 are given, and t1, t2 and t3 are also provided. So now to solve it with Gauss quadrature formula, we will convert the limit from 0 to 1, from 0 1 to minus 1 to plus 1, and also the x will be converted to t, and the differentiation will become dt from dx. Yeah, the differentiation will become dt from dx. So proceeding the question, let a is equal to 0 and b is equal to 1, the limits we are talking about. And here this expression x is equal to b minus a by 2 into t plus b plus a by 2 into t is to convert the value of x to t, so that the differentiation will get later will be in form of dt instead of dx. So putting values of a and b, we get x is equal to t by 2 plus 1 by 2. Now differentiating it, we get dx is equal to dt by 2. Now as we know, 1 by 2 is a constant, so its differentiation will become 0. Now substituting the value of x in the integral given, the dx by 1 by 1 plus x square, so that will become ft is equal to 1 by 1 plus, where initially it was x square, now it will become 1 plus t by 2 whole square. Now, if we solve it, it ultimately becomes 4 by 4 plus 1 plus t whole square, and we can change the limits as because we used this formula earlier, which was x is equal to b minus a by 2 into t plus b plus a by 2. So now the limits are minus 1 and plus 1 instead of 0 and 1. Now the now we know that the formula is ft is equal to, or phi t is equal to w1 phi t1 plus w2 phi t2 and w3 phi t3. So now solving further, as we know the value of W1, T1, W2, T2 and W3, T3. So we will solve for phi T1, phi T2 and phi T3. We will get the values such as phi T1 comes out to be 0.27976 and phi T2 comes out to be 0.4, and also phi t3 comes out to be minus 0.061836. Now further we can put all these values to the formula phi t is equal to w1 phi t1 w2 phi t2 and w3 phi t3. Now I pardon me for the previous equation where I have written ft1 instead of phi t1, so that's a mistake, please consider it. And putting all the values we get minus 0.55556 into 0.27976 plus 0.8888 into 0.4 plus all these values, and the ultimate answers comes out to be 0.138264. So this is our answer for evaluating the question using 3-point Gauss quadrature formula. Now for the next question, we are required to write algorithm for Vidal's rule for 6 points. This is comparatively a easier one because it is quite small compared to the other questions. Here we are to read start, which is the lower limit, and read end, which is the upper limit. And for the value of h is basically upper limit minus lower limit by 2 by 6. Sorry, it was actually upper limit minus lower limit by n, and then we will run a for loop from lower limit to upper limit and read yi for the respective values and then put it in the expression s is equal to 0.3h into y0 plus 5y1 plus y2 plus 6y3 plus y4 plus 5y5 plus y6. The initial formula was 3h by 10, and then y0 plus y6 are written together, so it is a tweaked version of that formula, and then at the end we can print s and obtain our answer. So this is the algorithm for Vidal's rule for the 6 points. Here points mean the intervals we have taken, means n is equal to the intervals we have between x0, x1, x2, x3, x4, x5, x6, x7. That means like in these values there are six intervals, that is n is equal to 6 or 6 points. Now for the next question, we are to write the algorithm for Rangakutta fourth order expression. Now we will define our function fxy, then return the whole expression. Then read start, end, and intervals. Here, start and end basically mean the starting and ending limit, and intervals are the uh, intervals between values such as x0, x1, and x2. Now the value of h is end minus start by n, and whatever the question is given. Now we will implement a while loop which runs until the start is smaller than the end. Now we know that in fourth order expression we have four different values of k which are later calculated in form of x. Then at the end we can write the expression start is equal to start plus h, and then we will get our expression y is equal to then the print statement can be written where the value of x and y will be printed. Last question, we have to apply predictor corrector method to solve dy by dx is equal to minus xy. Y0 is equal to 1 in steps of 0.1 up to y02. Here the predictor corrector method is also known as Hume's method, where we first predict the value and then obtain the correct value, and then in place of the predicted value we put our correct value and keep repeating the process until we are satisfied with the value. So here we will see the question. Here we have found the value of k1 and k2, then put it in k, which is nothing but k1 plus k2 by 2. Then yi plus 1 is equal to yi plus kh. Hence y 0.1 is equal to 9975.9975. This is the predicted value. And then to calculate the correct value, we are written the value of y 0.2 then it comes out to be 0.98005. This is the predicted value, and here at the end which is written y 0.2 is equal to 0.982712 is the correct value. And we will keep repeating this process until we are satisfied with the value. We will put the correct value in place of the previously predicted value, and we will obtain our answer. Thank you. Thank you for putting your precious time in watching my project. I hope you guys enjoyed it. If you have any problem, you can mention it in comments.